Good morning, dear conference participants. We greet you and wish you a good and productive day on climate change and atmospheric chemistry section. The conference provides opportunities to exchange the latest ideas, to present and discuss recent results and the physical, chemical and biochemical aspects of processes which take part in the ecosystem, soil, air, and water, and promising approach of sustainable development, including engineering and modeling, as well as social and education implications. The aim of the conference is to encourage and facilitate the interdisciplinary communication among scientists, engineers, economists, teachers, and professionals working on environmental issues and sustainable development. The first presentation will be dedicated to the corresponding member, Dr. Habilitat in Geography, University Professor Nedelkov Maria, former director of the Institute of Ecology, notorious specialist in climatology, meteorology, and environmental protection. Award is offered to Dr. Ala Donica, Deputy Director of Sciences, Institute of Ecology and Geography.
Good morning. Do you hear me? Dear participants, good morning.
Yes.
Okay. Dear participants of conference, Climate Change and Atmospheric Chemistry, at the beginning of this section, we ask permission to speak a short homage message about Professor Nedelkov Maria, a former director of our institute, Institute of Ecology and Geography, who died a year ago on the pandemic COVID-19 time. So academic Maria Nedelkov was a notorious personality in geography and climatology field, knew on local, national level, but also in regional and some international field or domain of geography and climatology. Nedelkov Maria, Professor Nedelkov Maria, was born in the south of Moldova in Cahul district, was a Dr. Habilitat in Geographical Science, University Professor, corresponding member, worked at the Academy of Science of the Republic of Moldova since 1982. So after graduating Faculty of Geography, specialty Geography and Biology of Tiraspol State University in 1982, she works at the Institute of Ecology and Geography. During these years, she passed all the steps of a scientific engineer in the laboratory of climatology, in the laboratory on the Department of Geography of Academy of Science of Moldova, was junior scientific researcher, one scientific researcher and scientific secretary of our institute, senior scientific researcher, lead scientific researcher, to the head of laboratory climatology environmental risk or of the within Institute of Ecology and Geography. During 2016-2021, she was director of Institute of Ecology and Geography and defended her doctoral and also postdoctoral thesis in geography of sciences on meteorology, climatology, and agrometeorology section. During her life, she published more scientific papers, monographs, teaching courses, implementation, practical recommendation, So she has developed 7 new indices with applicability in regional climatology and national level and abroad, such as Index of Dry Periods, Rainfall Excess Index, the Coefficient of Climate Suitability for Grape Quality, Rainfall Hazard Index, Thermal Variability Index, Variability Index of Thermal Singularities, and Forest Stress Aridity Index. During her scientific activity in the field of meteorology, climatology, agrometeorology, Professor Nedelkov classified for the first time the winter according to their degree of harshness and highlight the condition from some thermophilic kernel crops. Thus demonstrated the possibility of their cultivation in various areas. The detailed maps obtained were implemented within the State Commission for Testing Plant Varieties and scientific institution within the Ministry of Agriculture and Food and Industries certified with implementing acts and recommendations. So the obtained results were the basis for editing collective work with specialists in the field. Based on her estimation based on method by timesheets and the geographical information system, Professor Nedelkov founded a new direction, the agroclimatic regionalization of the territory of the Republic of Moldova regarding the degree of climate suitability for agriculture in general and for the development of fruit growing and viticulture in particular. Based on this result, obtained 2 monographs published, including a single author, Professor Nedelkov. So current environmental changes, special climate change, are leading climatology researchers to conduct complex researches and climate surveys. For the first time, Professor Nedelkov proposed at the regional level the concept of complex climate change estimation based on series trend, cycle component, and residual series. Thus, based on deterministic and stochastic methods, Professor Nedelkov highlighted the regional peculiarities of current climate change and possible climate change in the near future. So, was obtained atlas, the first scientific thematic atlas, climate resource of the Republic of Moldova, which also reflect the future changing of thermal and rainfall regime on a monthly, seasonal, and annual basis. For example, Atlas launch event was a scientific event new on national level. In the accelerated pace of climate change, which has been evident in recent times, the agrarian orientation of the country economy, the inability of agricultural branches to adapt to these changes, as well as the lack of intersectoral adaptation strategies, induces new need of new regional climate change research on the certain crops groups productivity. Professor Nedelkov shown that agricultural practices which will not take into account the negative effects of possible climate change and risk, soil degradation, environmental change, and biodiversity are likely to face a real threat to sustainable development. Under his leadership, made various climate projections and performing simulation on the harvest of agricultural crops in the country in the coming year. So based on the importance and necessity of implementing the Framework Convention on Climate Change and combating desertification and other national and international acts, legislative norms, was developed a strategy for some districts in our country, for example, districts from north and center of Moldova, also for some districts from south of Moldova, with recommendation for adaptation to climate change expressed by cartographic models on the current state of energy resources, heat, humidity, and winter conditions. Also, Professor Nedelkov known particularities of climate change at regional level and required the revision of a traditional complex indices, no estimation of a thermal and humidity regime. So for the first time, the impact of current climate aridity on the tree species in domain of silviculture is determined at the forest sector level as forest aridity index, the Ellenberg quotient, the Marton aridity index, the beach climate tolerance index, and forest stress aridity index. Also, under supervision of Professor Nedelkov, was developed few new indices with applicability in regional climatology, both national and abroad. For example, the index of dry period, the excess rainfall index, and the coefficient known as coefficient Nedelkov-Rapsa for climate suitability for grape quality. For example, this is the coefficient Nedelkov-Rapsa for breathability of vineyard. Under her direct supervision, 8 doctoral theses in geographical science were defined in the specialty meteorology, climatology, agrometeorology, and also in the specialty environmental protection and sustainable use of natural resources. Also, she was the president of the profile scientific seminars on this specialty and the director of the doctoral school of genomic science at the University of Academy of Science of Moldova. During her professional activity in this section, she was also a national expert in preparing various reports on climate change, integrated drought management in Southeast Europe, the vulnerability of Danube basin to climate change, organized various international bodies, also here in the Republic of Moldova and abroad. For example, here are some of these international bodies where Professor Nedelkov was very active. The achievement of Maria Nedelkov were appreciated surely national and international with academic and state distinction. Here are some diplomas and medals of Maria Nedelkov, her presence at different national and international scientific committee. For her was an honor to be a Doctor Honoris Causa at the university where she graduated, at the State University of Tiraspol, where was recognized her skilled administration, managerial administration, scientific capacity, talent, specialty in training and educate new generation. So in the end of this presentation, we have a pain in our soul. We launch this scandal for our former director of institute and wish rest in peace for Professor Nedelkov. Thank you for your attention. Our session program. We invite Professor Vladislav Komish from Russia, from Institute of Electric and Electric Power of Russian Academy of Science, if he is here.
Yeah, I'm here.
Professor Komish, you can share screen with your presentation. Okay. Please, Professor Vladislav Komish.
Thank you very much. Прошу прощения за задержку. мы подключились к другой секции, и вот сейчас переключились и пропустили первый доклад. Прежде всего, от имени Российской академии наук я хочу поздравить нашего почетного члена нашей академии, выдающегося ученого, профессора, академика, моего друга Георгия Дука с днем рождения, с 70-летием, и пожелать ему дальнейших успехов. Он не только выдающийся ученый, но и замечательный друг и человек. И я хочу пожелать ему и его семье благополучия, новых успехов в науке и всего самого хорошего. Спасибо. Разрешите приступить к докладу. On the tradition to green aviation. Today, airports in such big cities as New York, Paris, Moscow are located almost in the cities or near the cities. With the growth of cities and the increase in the number of air transportation, the problem of reducing harmful emission into the atmosphere, reducing noise and vibration is becoming more and more urgent. На следующий. Next slide. On the figure 1 shows the primary emission from the commercial aircraft. Carbon dioxide emission from the aircraft are a direct result of fuel hydrocarbons burning. Given the strong growth trends in air transportation, the aviation sector will be increasingly become an important source of greenhouse gases, and their impact on local air quality and global climate change is expected to increase in the future. According to estimates, greenhouse gas emission increased by 1.4% annually and CO2 by 1.8%. As one can see from the figure 2, the aviation sector consumes approximately 30% of the total fossil fuel used in the transportation, which corresponds to roughly between 2 and 3% of the total fossil fuels used worldwide. In addition to the terminal effect on the climate, traditional aviation has a strong effect on the quality of the ambient air, which is fraught with various lung diseases among the population of the planet. The main air pollutant from aircraft flights is nitrogen oxide. The next slide, please. To solve the problem of emissions, the principles of the green aviation have been development which are based on the optimization of the flight schedules, change of the design of aircraft, they use the lightweight composite materials, change of the principles of the operation, and design of the engine and the fuel used. Next slide. We can differ now.
Sorry, Professor, but we are on the second slide. The presentation is not moving and is not in the full screen. Maybe you can change it in the full. Переведите в полноэкранный режим, потому что мы на втором слайде, у нас ничего не меняется, картинка.
Сейчас, секундочку.
Вот сейчас на третий слайд перешло. То есть если вы нажмете F5, мы сможем это все видеть как на весь экран. То есть вы сначала ею поделитесь, презентацией, а потом нажмите F5. Вот мы ее видим, да, и теперь вот F5 нужно. Или внизу вот этот мониторчик перевернутый, который внизу презентации. Нет, сейчас вы вышли. А вот сейчас, да, опять.
Сейчас видно?
Видно.
Видно. Если нет на целый экран, ничего страшного. Вы просто слайды не забывайте, чтобы менять. Вы сами меняете слайды, хорошо?
Хорошо.
Давай.
Так. Какой? The slide 4. We can define now traditional aircrafts as Sukhoi Superjet 100, for example, and all electrical perspective aircraft as an experimental lightweight one and Fika 200 as prototype for the future power electrical aircraft we aim in the future at. We can note the particulars of the both of them at this moment. Among the peculiarities of airplanes with turbojet engines, one can note: first, long driving range, short time for replenishing the fuel tanks, uneconomical fuel consumption, greenhouse gas emission into the atmosphere, and high noise level. The main difference of the electrical aircraft from the traditional one is an electrical motor, which receives energy from the electrical sources like batteries or fuel cells. The main advantage of such aircraft is an absence of the emission and possibility to recharge batteries during the flight. But today, there are only low power all electrical aircraft because of high cost of the battery. It shows service life, long change time, and leads to short driving range. The next. Thank you. There is a way to solve some ecological problem in the near future by the using of hybrid power propulsion system in the aircraft. It will allow to make the during range longer and to reduce essentially the emission from the fuel burning and noise from the aircraft. It can be made if the aircraft uses the electrical power from electrical sources during the takeoff and landing, and the rest energy in the cruise mode from the turbojet engines. The sample of power distribution on the boat with a hybrid power propulsion system shows on the figure 6. AC generator provides most of the power required by the load. Supercapacity supply short-term peak power to the load transients. Fuel cell as secondary power sources supply power on the load. Battery supply or sink excess power in the system. Batteries also store regenerative power. Like technology was realized in the project by Airbus, Rolls-Royce, and Siemens. In the figure 7, hybrid 2 megawatts power plant of the flying laboratory IFAN is presented. It is worth to note that the DC bus voltage is 3 kilowatts. Kilovolts, excuse me. It allows to reduce the weight of wires on the boat and increase the power to the weight ratio. The next slide. But the first flight on the hybrid airplane was not today. It was on the 5th April of 1988 in the Soviet Union. In 1988, Tupolev 155 flying laboratory made its first flight. The power plant of which ran on the cryogenic fuel, liquid hydrogen. Experimental flights of the Tupolev 155 provided invaluable experience for the further improvement of aviation cryogenic fuel system. The next stage of the Tupolev 155 project was the conversion to the more convenient fuel, liquid natural gas. There were 3 engines on the boat Tupolev 155, 2 turbofan engines and 1 engine powered by hydrogen. A fuel tank with shielded thermal insulation contains 17.5 cubic meter of liquefied gas, together with fuel supply system and pressure maintenance system, was located in the rear fuselage. In the compartment constantly charged with air or nitrogen due to the structural difference of placement in the wind. The tank, pipelines, and units of the fuel complex had screen vacuum insulation provides the specified inflows. The next slide. Power DC-DC and AC-DC converters as an essential part of the power propulsion system for perspective electrical and hybrid aircraft. The voltage converters are necessary for correct transmission and distribution of the energy on board, as in an electrical as in hybrid aircraft. The power converters should respond to the following demands. First, high power density, high power to weight ratio, stable operation in event interface, reliability. Slide 8. To reach this purpose, promising trends in the development of the voltage converters for the power hybrid aircraft to be fixed. Use of high power silicon carbide transistors to increase the efficiency of converters, using unpacked semiconductor devices, transistor crystals on the board, using a multi-phase switch management system, application of high-speed microcontrollers and digital signals processors, increasing the voltage and DC bus to kilowatt, implementation of microchannel and cryogenics cooling system. Following this way, it is possible to construct the converters with a high power to weight ratio of the devices, tens of kilowatts per kilo, high efficiency of energy conversion, more than 99%, and with a long flight range. The next slide. Many companies deal with the development of the power converters for aircraft. Some of them on this picture are Cinemix from Fraunhofer. The slide shows the photos of such converters for batteries charging on the boat. The next slide, please. In our institute, the Institute for Electrophysics and Electric Power, Russian Academy of Science, as a part of the work with the Central Institute of Aviation Motors, there was also created a range of powerful DC-DC converters for battery charging on board. Among them, I can note our converter, a multi-phase voltage converter. Its power is 10 kilowatts and input DC voltage from 100 to 300 volts. The output DC voltage is 150 volts. It has current regulation. Its maximum output current is about 70 ampere. We managed to develop a compact device with small dimensions and power weight ratio about 3 kilowatts per kilo. The next slide. Our last development is present on this slide. This is 20 kilowatts DC-DC converter for battery charging on board. It's peculiarly in its high DC voltage. This device can operate in the range of the input voltages now from 800 to 1300 volts. Its output voltage and current are regulated. It has a digital control and fiber optics remote control. This device has better parameters in comparison with previous one. Its power to weight ratio is almost 10. It's 3 times better than first examples. And we hope to these parameters will be in future even better. The next slide, please. The other direction of institute work in the field of the green aviation trend is called gas electrodynamic flow control system for aircraft. It's new modern part of physics, which is called plasma aerodynamic. Today, we use plasma technologies to achieve control of aerodynamic flows is considered to be one of the most promising areas in aviation science and technology now. These technologies include atmospheric technology based on the interaction of discharged plasma ions with the air, which results in the formation of the electrodynamic flow. Plasma actuators, which are used to effectively impact the boundary layer of aerodynamic surface, serves as device for the electrodynamic flow formation. gas discharge is created about the surface of the dielectric plates in the jet formed by zinc, about 10 microns, on external and insulated electrodes located on the opposite side of this plate, to which a high alternative voltage is applied. The next slide, please. The use of plasma actuators of certain geometry and certain pulse power allows to increase the lift, control, and instability preceding laminar turbulent transition to the boundary layer or create volumetric flows with a high gas flow. For several years, our institute, in cooperation with the Central Aerodynamic Institute, have worked at the problem of aerodynamic flow control system for aircraft. The work is carried out in two directions. First, plasma actuators and power. Second, the power voltage generation of special pulse shape for their supply. For this time, we have developed a lot of plasma actuators construction with different geometry and different substrate. Our institute creates a range of powerful pulse generation of different shape, amplitude, pulse duration, and frequency. One of them is shown on the figure 17. This is 1 kilowatt generation is switch kilowatts pulses with regulated frequency and pulse amplitude due to constructed research on could be created the system. The generation unidirectional body force over length aerodynamic surface. Second, reduce the cross flow in swept wing boundary layer. Attenuate of stationary and stable vortices. Delay the laminar to turbulence transition. So I can conclude that our institute adheres to the principles of the green aviation and is working in this direction. Over the past few years, we have developed a number of powerful switching voltage converters as a part of powerful plants for electrical and hybrid aircraft, in particular for charging batteries aboard in aeroplane. Thanks to use of modern solid-state electronic components and ergonomic design, we have managed to achieve a power-to-weight ratio from units to 10 kilowatts per kilo. Now it's very close to record numbers. In the fields of low-temperature plasma physics, our institute is working as a gas electrodynamic flow control system for aircraft, which is one of the primary importance for the increase in aerodynamic and energy efficiency, thus solving the environmental problem of reducing emission of carbon and nitrogen oxide and significant fuel economy. Thank you for attention.
Thank you, Mr. Academician, Professor Vladislav Komish. Thank you for your interesting presentation needed currently for the transition to green aviation. So, dear participants, if you have some question, please ask. If has not.
Okay, thank you.
Thank you, Professor Komish Vladislav, academician of Institute for Electrophysics and Electric Power of Russian Academy of Sciences. Next in our section is Dr. Oleg Bogdevich from Institute of Chemistry, Moldova, with presentation spatial mapping of national emission of short-lived climate pollutants in the Republic of Moldova. Mr. Bogdevich, you are with
Thank you. Thank you for the invitation. Good day for everyone. Just a moment, I will demonstrate my presentation. So, our presentation is about the possibility of spatial mapping on national inventories, which was made in the Republic of Moldova last year. This inventory was developed by Institute of Chemistry within the project in this field, which was supported by United National Environmental Program. And this report is placed on the website, the respective website. The aim of this work was the improvement of air quality inventory in our country and the preparation of action which reduce air pollution of short-lived climate pollutants. This work was made in the cooperation with Institute of Ecology and Geography and Institute of Power Engineering and the coordination of Ministry of Environmental, but in that time was Ministry of Agriculture, Regional Development and Environmental. The respective short-lived climate pollutants as black carbon, methane, tropospheric ozone, and hydrofluorocarbons are most important after the carbon dioxide, which are responsible for the 45 of current global warming. It is a source from internet. Black carbon, it is a principal source is incomplete combustion of fossil fuel and biofuels and other different materials. Methane emitted by human activity as a leaking from natural gas systems and livestock production, as well as natural sources as wetlands and others. Hydrofluorocarbons also are made greenhouse gases, and tropospheric ozone is major air pollutants and green gas, which is formed in the interaction with different pollutants from industry, transport, energetic, and other sources. The mapping of these pollutants is a key element for the modeling of air pollutants in the region. Of course, this inventory is used as a base for the elaboration of this mapping. And the first step is elaboration of spatial emission in according to the EMAP guides, and for the possibility make the visualization of the principal air pollutants. The regular reporting of this inventory is not made in our country, but should to be made in the near future, after the approval of this procedure in our country. The reporting of gridded emission, this reporting is based on the gridded emissions with a resolution 0.1 grade, longitude, latitude. Also, it is a requirement of EMAP of European Environmental Agency. There is a special document for as a guidance for this mapping. First step is the preparation of initial data from nomenclature of reporting, which was submitted in EMAP site. And 25 air pollutants can be mapped after the preparation of the data from this report. The respective pollutants are presented on the slide. After the preparing initial data, the data will be placed on the special data, and which can be downloaded from the respective internet resources according to the guidelines. In this inventory can be used most used coordinate systems because the table of nomenclature reporting included additional columns with coordinates. These coordinates also were obtained from the GIS processing of initial data and creation of proxy files after the data relocation. We use several open sources for raster GIS data, which is can be used in this mapping and as a reference information for the future analysis of different emissions. And also vector data can be used in this work. The respective vector GIS data are available in the internet. As an example of the utilization of vector data for Moldova, from one side can be downloaded vector data as points, lines, polygons in different formats. The respective shapes which can be processed in different GIS software. For example, from Moldova, we use roads files, land use, and other information. It is an example of gridded nomenclature form for reporting. We can see only the two columns as longitude and latitude is additional columns to the answer data, which was produced yearly. After the downloaded of grid for Moldova, we can report it all pollutants according to these grid files. The QGIS software, as usual, can be used in this work because this software is free for the utilization and can be used for the initial work in this activity. It can be used by our administrative units and other institutions which are responsible for this reporting. It is an example for the demonstration of map from OpenStreetMap internal sources. It is a demonstration of grading for our country, which was downloaded from the respective sites, and we can use this software for the visualization of this grid and creation of proxy files. I demonstrate only examples because there are a lot of pollutants, and I demonstrate only the base for the data processing. It is an example of the processing of roads network in our country. This shape also can be used free from internet, and we can calculate the density of roads for every grid. After the grading of our pollutants and creation of proxy files, we can combine the density of roads with different pollutants by different category of inventory, as transport, energetic, and other categories. It is a demonstration of we obtained the point information after the proxy file creation for every grid is the information for every pollutants from nomenclature for reporting. This procedure is very clean and easy for the understanding of for the processing. After the obtaining of proxy files, we can make a visualization of different pollutants. It is examples of azote compounds emission from transport. We can see the hot points of these pollutants and the intensity, because it is it was processed as for the spatial fixing of the emission in our area. It is example from non-methane volatile organic compounds, also from the transport. We calculate the density of roads, density of transport, emissions. It was a work principle in the creation of proxy files for the modeling and the report, further calculation. Also can be used from internet data for the density of population, for example. It is also important for the calculation from energetic sector and transport, because the population is an indicator of the energetic consumption and transport intensity, for example. There's several examples of using other software in this calculation, for example, MapInfo software. MapInfo more professional as QGIS and can be used by professionals in the modeling, interpretation, and movement of these higher pollutants in the surrounding territory and other impact to the climate change and air quality in the region. After this work, we can conclude this our inventory, which is can be processed by the gridding according to EMF grid requirement, which cover all major pollutants from the inventory report. QGIS software demonstrates as a good solution for the analyzing and mapping of the climate pollutants, for the interpretation of any environmental informations and implementation in the, for the decision making, and make this work can be made by not professionals, as students, aspirants, and administrative representative from respective agencies. This application allows to create informative and visual resources with the results of our research in this field, and using GIS programs. The results showed the hotspots of principal emission, which can be used for the decision making in this area. This methodology will be used for emission inventory and reporting of Republic of Moldova in the near future. We have experience and can produce this work, but it depends on the decision of our respective authorities. It is our report, informative report for this inventory, and thank you for the attention.
Thank you, dear Dr. Bogdanovic, for your presentation, currently needed presentation, because the Republic of Moldova is part of many conventions, national documents that regulated with need of inventory. So, dear participants, if you have some question, please ask Mr. Bogdanovic. Thank you, Dr. Bogdanovic. According to our program, the following report speech is from Kazakhstan, Dr. Sarik Burbitayev. If you are here. No. So the next is our presentation of Dr. Inga Zinkovskaya from John Institute for Nuclear Research, Russia, with a speech nuclear analytic techniques in ecological studies, Moldova case study. Please, Dr. Zinkovskaya.
Thank you very much. Please confirm if you can see my presentation.
Yes, you have your
And I would like to transfer it in the full screen mode.
It's okay. Then.
Yes, thank you very much. I would like to mention at the beginning what I represent 3 institutions, actually. It is Joint Institute for Nuclear Research, Institute of Chemistry in Chisinau, and Hore Holubei National Institute for Research in Physics and Nuclear Engineering in Romania. Today, I would like to present the data which we obtained for Republic of Moldova on air quality studies. Air pollution is a problem which every country faces. It happens because there are no borders for the pollutants, and we have as a final result the global air pollution. Even we can say what we have some regional pollution sources, but at the same time, we also know what many pollutants are transferred on very long distances, contributing to the pollution of the countries where maybe some even some industrial enterprises are not operated. Speaking about the assessment of air quality, of course, we can use traditional techniques like, for example, filters, but not always it possible because of the high price of these techniques and the limited area where they can be placed. In this case, the best solution for this is application of biological indicators. Because biological indicators we can find on the large territories. They are growing, they are very abundant, and they have a high capacity to accumulate heavy metals, organic pollutants from the atmosphere. Speaking about air pollution, there are 2 main indicators which are widely used by scientific society. The first ones are lichens, which are usually growing on the tree. They're also growing on the soil. And the second, and maybe the more popular, is use of mosses for assessment of the air quality. The application of mosses for the assessment of air quality is already a long story because it is an initiative which was established at the beginning of 90s by 3 European countries. It was Sweden, Denmark, and Norway, which proposed to use moss like biomonitors on the large scale to monitor the state of the environment, firstly in these 3 countries. After that, the program enlarged and more countries joined this program. And we can say today we have already around 25, 29 countries participating in the program. If firstly it was established like the European initiative and just countries from the Europe participated in the program, in the last years, since the part of the program related to heavy metals was transferred to Joint Institute of Nuclear Research, countries which are member states of the institute, like for example, Vietnam, Kazakhstan, Azerbaijan, even there are no European countries, they also joined this program and they started to report the data. So how the program work is very simple. Every 5 years, it is announced the moss survey. So we have now running the moss survey 2020 to 2022, when countries start to collect moss samples on their territories. It is supposed like every 5 years, mosses should be collected on the same sampling sites. After sample collection, the data are reported to ICP vegetation program and are edited such type of atlases, which include the information about elements. At the moment, there are reported 11 elements to this program. There are presented the data on these elements for every 5 years. What is from the last survey, which was performed 2015-16, in total, more than 5,000 samples. Most samples were collected in countries. Here there are represented just the countries which participate in this program. And sometimes the question arises, why MOS is used like biomonitor for air quality? The answer is very simple. MOSes don't have very well developed root system, and it is supposed that they accumulate these elements mainly from the atmosphere. The main, let's say, advantage of this atlas is what we can trace how the situation in the countries which participate in this program change during this period when they participate. So you can see what, for example, the concentration of lead was significantly reduced from 90s to 2015, almost by 80%. It explained by the fact that many countries, they adopted rules which restrict the use of leaded gasoline. That's why just one, let's say, order, which was established by many countries, resulted in a significant reduction of the load of lead on the environment in many European countries. The same is the situation with cadmium in vanadium. In the case of these elements is also observed a significant reduction. It can be explained in several ways. One, in some European countries, these ecological rules, let's say, they are very strict. They moderate the enterprises, including some filters which just capture these emissions. In other countries, like for example in Romania, Bulgaria, some of these enterprises, they just became very old and they were closed, just reducing the impact on the environment. For other element is maybe not so evident, the reduction of the concentration, but in any case, Atlas help us to understand what is the level of pollution of the atmosphere in many countries which participate in this program. Speaking about the Republic of Moldova. Sorry? Speaking about Republic of Moldova, Moldova joined the program of ICP vegetation program firstly in 2015, when we collected mosses on the territory. In Moldova, there are two types of sources of emission of pollutants in the atmosphere. The main parts are stationary sources of air pollution. They include free power and heat generation facilities, a lot of regional, interregional, local boiler houses. There are also gasoline and gas station, and one of the most important mobile source of air pollution, of course, it is transport when we speak about cities and towns especially. In 2015, we collected in Moldova 34 samples, most samples. We tried to cover the entire territory of the country. Most sampling usually is done according to MOS manual, which just inscribe the main conditions which need to be respected during this MOS collection. So the black points which you can see on the map, there are sampling sites. We use two analytical techniques to determine the elemental composition of these MOS samples. The first one, it was neutron activation analysis, which allowed us to determine the wide range of elements and free elements, which are very important from the environment point of view, what it is not possible to determine them using activation analysis, copper, cadmium, and lead. We use the supplementary technique. It was atomic adsorption spectrometry. About samples irradiation, a few words. Neutron activation analysis was performed in the past-fast reactor IBR-2 in the Joint Institute for Nuclear Research on the installation Regatta, which is located here. Regatta is one of the 14 installations of the reactor where we perform our scientific investigations. The technique is based mainly on the reaction of the neutron capture. When the neutron is captured by the nuclei, we obtain the compound nuclei, which is coming to the normal state by the emission of the gamma radiation. So we can just register this radiation using high pure germanium detectors and already process this gamma spectra which we obtain. Activation analysis is analytical technique which have a lot of advantages, and of course, like every analytical technique, several disadvantages. Speaking about the advantages of the technique, I would like to mention it is high sensitivity and selectivity, is technique absolutely not dependent of the metrics of the samples which are analyzed, is not destructive technique. In comparison with ICP-MS, atomic adsorption spectrometry, we do not need to dissolve samples in acids. We work with solid samples. Is not dependent also of the chemical form of the element. At the same time, is a technique which allows us to determine more than 45 elements in different kind of samples of environmental, geological, biological samples. And as disadvantages of the technique, if you would like to apply this technique, you need to have a nuclear reactor, firstly. The second, let's say disadvantage, but in case of some samples, even it is advantage, is the time which you require for analysis. So for example, using atomic adsorption, you can obtain the results very quick. But in our case, if we need to determine the full set of the elements, we require like around 2 months for analysis, for radiation analysis and processing of the data. And of course, we obtained samples which became the radioactive waste, and they required the special conditions of storage. So in case of MOS, the procedure of sample preparation is very easy. You can see it here. We clean mosses from different impurities like pine needles, leaves, and so on. We collect usually the green part of the moss. We make such kind of pills because it's very voluminous. We weigh these samples, we pack them, and we have 2 modes of irradiation. First one for determination of elements with short-lived isotopes, the second one for determination of elements with long-lived isotopes. So there are 2 ways of sample irradiation. As a final result, we can obtain the concentration of the elements which are marked in green. And as I mentioned previously, 3 elements marked in red. We use another technique. Speaking about copper, in some cases, when the concentration of copper is high, we can even determine it using neutron activation analysis. For cadmium and lead is not possible, even at high concentration. On the set of the data which we obtained for Republic of Moldova, we determined the concentration of 38 elements. Is a huge set of data, which is usually when we'll present like the Excel file, nobody will understand what it is. So the best way is, like in the previous presentation of the Dr. Bogdevich, is to make maps, to build maps of the distribution of the pollutants. Since the set of data is very big, what we are doing, we process the data statistically, and we try to find the association between elements. So we use the factor analysis, which help us to, let's say, to divide these elements in groups. And our main scope is defined what is the source of these elements. For example, for the set of the data which we obtained in 2015, we divided 3 main factors. You can see what the first factor included a large number of the elements. And usually we define it like geogenic, anthropogenic association of the elements. Why geogenic? Because it includes some elements like, for example, thorium, uranium, rare earth elements, aluminium, titanium, which main source we can consider the deposition of the soil particles. It is known what in Moldova climate is dry, and the main part of the territories, there are arable soils. So the soil particles, they can be transferred on the long distances. But at the same time, we have elements like, for example, arsenic, vanadium in this group of elements, which can be also emitted by the thermal power plants when oil and some heavy oils and in coal is used like fuel. That's why this factor includes 2 groups of the elements, and the main contributors in this case were belts, Chisinau, and Rezina. The second factor included 3 elements. It was chlorine, selenium, and strontium. Even consider what vegetation of the high plants can be one of the source of the accumulation of these elements in mosses. The second factor is anthropogenic ones. This include 3 elements, is cadmium, zinc, and antimony. It is already well known was these three elements a tracer of the transport emissions. You can see what the highest concentration of these elements we determined in Chisinau, and the second place it was resina. But in resina, in this case, it can be not just transport the source of these elements, but also cement production can contribute to emission of zinc and other elements. I would like to mention what we didn't collect samples in Transnistria, and most probably what in case of resina, we can have also some influence from this part of the Moldovan territory as well. We calculated several indices just to understand the level of the air pollution in the country. We selected just elements which we consider like environment pollutants. So we calculated the values of the contamination factor, enrichment, and pollution load index for Moldova for the whole territory using the whole set of data, and for Chisinau and Belt separately. So usually is considered like the value of the contamination factor are between 1 and 2. We can say what we have no contamination or just suspected contamination. When values are higher than 2, we can say what we have already moderate pollution, and at values higher than 6, 7, we can speak about the severe pollution of the environment. So the territory of the Moldova can be characterized like unpolluted to moderated polluted depending of the element. The only element we contributed to the severe pollution in Chisinau, it was uranium. So we obtained very high value, it was 12.5. We consider like the main source of the emission is burning of the fuel on the thermal power plants. Especially, it is well known what if coal is used like fuel, it is enriched in uranium, arsenic, and some other elements which contribute to the emission in the atmosphere. Data which we obtained from Moldova, we compared with other European countries which participated in this program, ICP vegetation program. Data for Moldova marked in red. You can see what for some elements, for the main part, let's say, of the elements, values are very high in Moldova, and for vanadium, the highest value we obtained. But at the same time, our values are very close to our neighbor, to values which are obtained for Romania. In this case, beside national, some, let's say, local sources of the pollution, it is expected that there are also some transboundary pollution of the atmosphere. In some national reports in Moldova, for example, I found what even Ukraine, Poland, Romania, in some ways, they also contribute to the pollution of the air in the country. The second survey was performed 2020, so we have already data for the second survey. In this time, we enlarge the area of sample collection, because in the first survey, it was not possible for us to collect mosses in the south part of the country. But in 2020, we collected mosses in this part as well. Again, the same two analytical techniques we were used to determine the elemental composition of these moss samples collected in Moldova. And we applied the same statistical tool just to understand what sources of air pollution can be defined in this case. So in 2020, we already divided 4 sources of air pollution, but it's very interesting because you may see what the first factor and the fourth factor, they're almost the same like in 2015. So we have, again, geogenic, anthropogenic pollution, belts, Chisinau, the main pollution, like the main pollutants and emitters of these elements. Factors include, again, elements which are tracers of the transport emissions, but at the same time, we have 2 new factors. It is second factor, which includes manganese, calcium, and strontium. For these elements, we suppose like mining activity in Moldova, there are mining of clays, limestone, gypsum. They can be one of the source of the emission of these elements and their deposition mosses. And the second source include chlorine, potassium, bromine, and copper. So if we can see this chlorine, bromine in some areas near sea, we can suppose like there are some impact from the sea. In case of Moldova, our suggestion is what this is the main contributor of the emission of these elements is agriculture. because a lot of fertilizers, pesticides containing these elements are applied, and they can significantly contribute to accumulation of these elements in most samples. Next stage, what we did, we tried to compare the data which we obtained in two surveys, in 2020 and 2015. Is interesting to mention what in 2020 we observed a decrease of the concentration of the main part of the element. So zinc was the only element which content increased in 2020, but applying Wilkinson test, we found what significant differences were found for lead, cadmium, copper, chromium, arsenic, and antimony. So the most significant reduction which we obtained, it was for lead. Firstly, we're thinking why it happens like this. 72% is really significant reduction. But just 1 week ago, I participated on another conference in Chisinau, where one of the colleagues from the Institute of Geography, she just showed the presentation about phytoremediation of the lead. And she said what in 2015, Moldova adopted this order to restrict the use of leaded gasoline. So in 2015, most probably we collected mosses before. And in 2020, after 5 years, you may see what the content of lead in most samples was reduced by 72%. Just one decision and such significant reduction of the elements content in most samples. The next stage, what we did, we tried to find using principal component analysis, just to understand if the sources of the air pollution in two surveys and elements which contribute the pollution are the same. So you may see the data for 2015 and the data for 2020, and in both surveys, Belts, Chisinau, and Rezina are the extremes. So there are the places which contribute mainly to air pollution in the country. Speaking about the elements, it's the same. You can see what in both surveys, cadmium, lead, and zinc, they form the same group of the elements. So the transport is one of the source of air pollution in the country. The second group of the elements, including copper, antimony, nickel. So in this case, we can say what we have contribution from the deposition of the soil particles and some industrial activity, and the impact of the industrial activity, which is mainly developed in these big cities. The rural area samples which were collected mainly in the rural area, they form just one cluster. So we can very clearly define, and we can just affirm that in both surveys, we have almost the same sources of air pollution. So during 5 years, nothing significantly changed in the country. For 2020, we also calculated the values for this contamination factor for Republic of Moldova, for Chisinau, and for Belt separately. You can see here elements which contribute mainly for air pollution in both cities. In Chisinau is mainly arsenic and antimony, and 4 elements in Belts. The technique about what I was talking is passive biomonitoring, but since Chisinau showed to be the most polluted place, we decided to perform also active biomonitoring studies in Moldova. We collected mosses in the region, we packed them in such special bags, and we exposed these moss bags in 3 places in Moldova. It was the building of the Academy of Science, Botanical Garden, and thermal power plant. Mosses were exposed for 5 months from October till March in 2018. 1 sample was kept here in laboratory in Dubna, like the control sample. And after that, we just calculated the relative accumulation factor values for these elements. So what we noticed the significant accumulation of antimony, of uranium, and other elements in most samples exposed in Chisinau. And here there are also the distribution of this concentration of the elements by months. The orange line which you see is the concentration of these elements in control moss sample. So the most significant increase of vanadium, antimony, arsenic, and concentration we noticed on the thermal power plants. As I previously mentioned, burning of the fuel is one of the main sources of emission of these elements. Antimony high concentration were also determined on two other places of the exposure. It can be explained by the fact was transport is also one of the emitter of the antimony. In case of iron, even we cannot define this source, but we can suppose what deposition of soil particles, again, transport or just weathering can be like responsible for deposition of soil particle on these most samples. And in case of arsenic, again on the thermal power station, it was like the main. So performing these two type of biomonitoring, passive and active, it was possible to determine the large number of the elements in most samples collected in Moldova and to define the main pollution sources. We can consider now performing both type of biomonitoring like thermal power plants and transport contribute significantly to emission of these elements in the atmosphere. And I would like to thank you for your attention. And I would like to propose to Professor Bogdevich to use our data also maybe for mapping, for creation of these maps, which are used by, after that in this program of assessment of the air quality in the country. Thank you.
Thank you, Dr. Zinkovskaya, for your enlarged, currently interesting presentation. We mentioned such kind of activities and such kind of experiments with passive and active biomonitoring was made also in some doctoral phases within Institute of Ecology and Geography. So in this case is very interesting for us your presentation and possible future connection with you in enlarge and make some common research in this area. So dear participants, if you have a question to Dr. Zinkovskaya, please ask. Thank you, Dr. Zinkovskaya. According our program, the next reporter is from Russia, Yulia Malova, from Ivano State University of Chemistry and Technology. Yulia, you hear me? Do you hear me? Are you with us? No. So, Dr. Omar Ligava from Russia joined Institute for Nuclear Research.
Hello. I can make a presentation.
Yes, Dr. Cheligava has a presentation about most biomonitoring of air pollution in Georgia. Is like interconnection with the Dr. Zinkovskaya presentation. So please, Dr. Cheligava.
Greetings. My presentation will be about most monitoring of air pollution in Georgia. First of all, I'll start with the study area. Georgia is a mountainous country located in the southern part of Caucasus. The landscape within the national borders is quite varied. Western Georgian landscape ranges from low land, marsh forests, temperate rainforest, thermal snow and glaciers, while the eastern part of our country even contains small segment of semi-arid plains, and about 40% of the country is covered with forests, and about 10% of the country is subalpine and alpine meadows. So the territory is very varied, and we participated in the monitoring program since 2014. As Inga Zinkovska has already spoken about this program, I'll just show you, for example, the distribution map of lead, which already was already mentioned. And in this program, it provides about information about 12 elements, nitrogen, and persistent organic pollutants in mosses. For example, I showed here the results, our first results about Georgia, for example, as in case of lead. Here we can see that Georgia is quite contaminated with a lead. Again, one of the main reasons is the transport in the gas zone, or some restrictions only came now, and we'll see the difference in future, I hope. About sampling, for the sampling of mosses, we used moss manual. Samples were collected during the period from April to October. The sampling points were located at least 300 meters away from main roads and highways and villages and some industrial places, while 100 meters away from smaller roads and houses. And for each sampling sites, up to 10 subsamples were taken in the area of 2,500 meters. Here we can see our previous sampling map, where we collected about 120 samples, covering the biggest part of our country. Here we can see our new sampling map, which we started our new survey in 2019. Unfortunately, in 2020, we were not able to collect samples. The other problem is that not all the samples were analyzed. That's why I write 35 samples. I will mostly today speak about, in the central part, about the samples which were collected in the central part of Georgia. Because of reactor which was closed, we were not able to analyze in time the samples which are already collected, but not analyzed. But we'll do it soon with that difference. Most samples we collected flowers and shrubbery, Heliconia splendens, Hypnophorus forma, which are the mainly used most species for passive monitoring. And we added Aviatina, La Aviatina for covering other territories where we can find this mosses. Analysis. 41 elements were determined using Neutron analysis and on the regat facility at either to reactor. And to fill the gap, we used a complementary method, atom pressure spectrometry for cadmium, copper, and plutonium. For data analysis, multiple statistics was applied. Principle of analysis allowed us to distinguish 4 factors associated with different sources. Here you can see 3 factors on this graph. And the dispersal of factors scores over the study area were built using RDs. Here you can see the first factor, as Olaf said, mainly the first factor is associated with soil dust. It is contribution of light and heavy cross component elements. The second factor is chlorine, potassium, zinc, salmon, brom, iodine, and copper. The main possible reason of these elements is agricultural activity, as the elements are often used in fertilizers. The third factor is arsenic, antimony, and tungsten. The village of Uravi, the main reason why we had this factor is this location, which is Uravi village, which was a mining and chemical factory function during the Soviet era in this area. And arsenic has been mined there about 60 years. And there left some burings and waste of arsenic. Fourth factor is cadmium, plutonium, and boron, which is mostly anthropogenic. I'll speak a little about arsenic. Factor for arsenic was observed in one single location in 2016, however, all the other arsenic measurements showed no anomalies. It was quite strange to see such a big concentration. It was 83.3 milligram per kilogram in Moses, which is a very high concentration. We decided to increase our sampling dots in that area to see how much it is, what has changed there, and what is the situation overall in that part, in that village. In Uravi, arsenic mining sites were abandoned in 1992, and approximately 100,000 tons of waste containing arsenic were left on surface areas. So in 2019, when we take at the same place, it is interesting that the concentration has decreased already 3 times. Mean in the region is 1.1, which is high, but not catastrophic as 83. And the mean in the country is 0.7 milligram per kilogram. So it means that exactly that location where we take a sample was quite contaminated with arsenic. And the main reason was the flood which has happened in 2011. Also about 5 years and 3 years are needed to decrease the concentration of arsenic at the location. 3 times. Monitoring provides a cheap and efficient method to deposition analysis for the identification areas at risk from atmospheric deposition of heavy metals. Considerable potential ecological risks of arsenic still exists in the environment of the village Uravi, and the data might be used as a baseline data for the air pollution deposition and to hold up any possible dynamics of the air pollution in Georgia. Thank you for your attention.
Thank you. Thank you for your presentation. And dear participants, if you have some questions about this presentation, please ask. Thank you. Thank you, Mr. Chaligava. So dear participants, we propose to have a small break till 11 and 15. And then come back to our presentation and our section. We have 4 more presentations from Russia and from Moldova. So we stand here, and we have now a break till 11 and 15. Okay. Do you agree with me or no? Okay. Short break till предыдущий пункт Что? Dear participants, welcome back to our climate change environmental chemistry section. According to program, we follow with presentation of Constantin Virgil. Dr. Constantin Virgil, are you with us? No, so Dr. Vladislav Svozilik.
Sorry, you asked me? I'm Konstantin Virgil. I'm before Vladislav.
Konstantin Virgil.
Yeah. I'm here.
Oh.
Sorry.
Welcome back. So, dear participants, the next presentation is of Konstantin Virgil, Dr. Virgil from Gion Institute for Nuclear Research, Russia, with assessment of atmospheric deposition in Central Russia. Please, if the floor is yours, Dr. Konstantin Virgil.
Thank you. Do you see my presentation? Yeah.
Yes.
Okay. Hello, everyone. I would like. Oh, I switch on web camera. I would like to present you results about biomonitoring project in Central Russia. As Inga said, thank you for my colleague, for head of our department. She described this program very well. ICP, our biomonitoring project also was done in the framework of the same ICP project program, and you hear about it, very popular. As Inga said, this program have a special monitoring manual where describe all parameters where you should collect mosses, how to collect, and so on. Many questions. So according to this manual and our experience, we collected samples in our regions. So during summer period in 2018 and 2019, we collected samples in Moscow region. We collected 156 samples, 72 samples in Vladimir region, and 53 samples in Yaroslavl region. So, as Inga said, it's a really good alternative method for estimation of air contamination, because during this short period we managed to collect samples from the area approximately 100,000 square kilometers. So, as a main analytical method, we use neutron activation analysis. And also for copper, cadmium, and lead, we use atomic absorption. And the combination of these methods allow us to determine concentration of 35 elements in mosses. I forgot to say that on all three regions we collected Pleurozium schreiberi moss species. In our geographic zone, you can easily find this moss species in our forest. So we try to understand possible sources of these elements, and for these purposes, statistical methods allow very well. And of course, we use factor analysis. So factor analysis in Moscow region show us 5 possible groups of sources. And first group, it's usually a combination of geogenic and anthropogenic factor. We usually call it soil factor. The second factor, it's industrial it contains rubidium and cesium. In some industry, they use these elements in micro scheme and so on industries. Third factor, it's transport. It's a combination of zinc, cadmium, lead, and copper. Factor 4, it's vegetation factor. It's macro elements, and factor 5, it's industrial factor. You see a combination heavy metals in this group. And on the maps, you see distribution factor 3 and 5. Factor 3, it's transport. It's evenly distributed over the whole territory of Moscow region. And factor 5, high concentration on the eastern part of Moscow region and around Moscow, so-called satellite city that supplied products to our capital. For Vladimir region, factor analysis showed us 4 possible sources of these elements. Its first factor, it's again a combination geogenic and anthropogenic factor. The second factor, it's transport. You can see elements that included in this factor. Third factor, it's soil, rubidium, cesium, cerium, and thamarium. And the fourth factor, also macro elements. And on the map, I showed the second factor and the high concentration on the western part of this region. That's really close to Moscow region. It's on the border of Moscow region, and also high content in the vicinity of cities, towns of these regions. And for Yaroslavl region, factor analysis reveal us 5 factors, and factor 3 and factor 5 showed us anthropogenic contamination, anthropogenic sources. It's industrial sources. For factor 3, it's high concentration in Yaroslavl, Tutaev, and Rybinsk. In these towns, concentrated all industrial enterprises. It's motor industry, oil refinery, and other chemical industries. And factor number 5, it's also industrial and transport factor. And a high concentration for factor 5, we see for this element, vanadium, zinc, antimony, and lead, we observed around Yaroslavl city. It's a center of this region. And in this city, in Yaroslavl, there is a huge oil refinery plant, probably the biggest oil refinery plant in central Russia. We also calculated ecological indices, and you can see it in a table. And according to these indices, general situation in Moscow region quite good, or not Moscow region, in investigated regions in Vladimir, Yaroslavl, and Moscow region, quite good. And contamination factors showed us that there are no contamination or suspected contamination. And only for Moscow region, if we calculated separate contamination factors for eastern part that I showed with high concentration, in that part we can observe moderate pollution for contamination. We have a project from We also have data from different biomonitoring project of Russia. And on these graphs, you can see that in investigated area, quite low concentration comparison compared to other regions. Only for antimony in Moscow region, one of the highest level for contamination. Antimony, it's the element that show us contamination by transport. And in Moscow region have a lot of highways, roads, a lot of transports in Moscow region. That's why in this region high level of antimony. So in investigated area, many main pollution sources, it's transport and industries. And the biomonitoring method help us to understand it and help us easy evaluate this situation. And I would like to say thanks for my colleagues that helped me on every step from collecting moss to process results and for handling radioactive samples. And thank you for attention.
Thank you for your report. We saw a large report from Institute of Joint Institute for Nuclear Research. So, dear participants, if you have some questions, please ask. No, thank you. Thank you, Dr. Konstantin Vergel.
Thank
And
you.
next presentation is present.
Permiteți o întrebare?
Do you have a question? Okay.
Oh, very good.
Спасибо. Можно я буду на русском, потому что английский не совсем понимаю и не владею английским?
Конечно, можно.
Конечно. Здравствуйте.
Здравствуйте.
Скажите, пожалуйста, вот вы выявили, что у вас как бы разные уровни загрязнения, все такое. Вот мне интересно, вы сделали какую-нибудь взаимосвязь между вашими показателями, которые вы выявили по разным этим содержаниям, и климатическими факторами, как они как бы повлияли на показания температур, осадков, проявляется ли как-нибудь это в виде кислотных дождей, все такое? Есть у вас такие как бы измерения, такие?
Таких данных у нас нет. Потому что мы работаем в рамках этой программы и в основном изучаем тяжелые металлы, и органические соединения мы не исследуем, например. Да, и у нас даже в рамках одной программы возникают вопросы по тому, за какой период, например, мхи накапливают это. 1 месяц или год, или 5 лет. Поэтому это все еще обсуждается в рамках этой программы. Но конкретно, например, изучение влияния влажности в июне на содержание в августе, таких работ не было.
Можно я добавлю? Можно я только добавлю? Мы на самом деле в 2020 году, да, мы пришли, мы после того, как у нас был некий локдаун в Московской области, мы посмотрели, мы собрали мхи в 19-20, сравнили, насколько локдаун повлиял на изменение содержания элементов, да. Если говорить о части Московской области, которая близко к Москве, там, в принципе, ничего не поменялось. Часть, которая была дальше, да, в нашу, например, сторону, у нас сильно уменьшились вот те элементы, которые являются трейсерами транспортного загрязнения. И мы тогда же и решили, это мы, наверное, уже на следующей конференции покажем, у нас была бесснежная зима и снежная зима. Вот мы собрали мхи после бесснежной зимы и после снежной, вот как раз чтобы оценить, влияет ли вот этот снежный покров каким-то образом на накопление элементов, но у нас, к сожалению, пока не готовы эти данные.
Анализ не проведен.
Но проблема в том, что когда мхи собираются раз в 5 лет, это перспектива дальносрочного загрязнения, а не быстрого загрязнения, которое там легко отследить.
Спасибо.
Но иногда эти концентрации могут влиять и ветра. направление ветров, наверное, тоже иногда у вас вот да, доминирующие ветра. Я тоже...
Да, доминирующие ветра. У нас многие спрашивают, как мы используем направление ветра, но на самом деле сеть пробоотбора такая частая, что мы уже на самой сети видим, что у нас западные ветра в основном преимущественно в нашей зоне. Мы даже когда строим карты распределения, мы видим, что само загрязнение вытягивается с запада на восток. Потому что сеть достаточно частая пробоотбора. Там между точками порядка 20 километров.
Okay, thank you for your question, for your interesting presentation and our interaction. So, the next presentation is Vladislav Svozilik, doctor.
We do not see him. I don't know why.
Okay. Alena Botnar from Institute of Ecology and Geography with presentation from impact of climate change on the date of dangerous frost manifestation on the territory of the Republic of Moldova. Alena, please share your screen. Pune prezentarea.
Imediat. Așa. Îmi spuneți, vă rog, dacă se vede. Acum și imediat. Îmi spuneți dacă se vede, vă rog.
Da, se vede. Puneți-o pe primul slide. Așa. Apăsați, da. Ok, bine.
Voi vorbi despre impactul schimbărilor climatice, anume asupra datei de manifestare a înghețurilor pe teritoriul Republicii Moldova, pentru că vedem că și înghețurile sunt un fenomen climatic de risc care aduce daune agricultorilor și în analiza efectuată pentru anii 2005-2020 ne arată că și acest fenomen a fost cumva dereglat, să spun așa, de către schimbările care au loc la nivel climatic. Este indiscutabil că schimbările climatice au loc și acestea au un impact negativ asupra tuturor activităților umane. Ele cumva perturbă evoluția normală a tuturor activităților umane și mai ales au un impact foarte nefast asupra celor care se ocupă de agricultură. Toate aceste perturbații au loc, se soldează cu pierderi economice, deoarece fenomenele devin destul de imprevizibile și au un impact de amploare. De exemplu, nemijlocit, dacă ne referim la înghețurile care au loc în afara perioadei reci, impactul are loc asupra vegetației, a culturilor de viță de vie, a semănăturilor de toamnă. Cercetările efectuate asupra acestui fenomen au stabilit că o corelare direct proporțională între daunele produse și data de manifestare a înghețurilor. Acestea sunt cu atât mai periculoase cu cât se manifestă în faza de formare a rudimentelor productivității, care datorită temperaturilor ridicate, unele plante ajung în faza medie de dezvoltare și astfel de scădere bruște a temperaturii devine destul de stresantă pentru culturile agricole. Aceasta se exprimă prin degerături sau chiar moartea plantelor. Astfel, înghețurile ating magnitudinea unui stres ecologic. Dacă analiza datelor medii multianuale ne arată că primele înghețuri se manifestă în prima decadă a lunii octombrie și se termină în a doua decadă a lunii aprilie. Desigur, cu careva diferențieri teritoriale destul de semnificative, uneori chiar și de 5 zile de la nord spre sud. Calculul statistic a stabilit că perioada supusă studiului 2005-2020, cel mai târziu îngheț a fost înregistrat la stațiile meteorologice Soroca și Kamenka, 10 mai 2017.
Doamna Botnar, dumneavoastră schimbați slide-urile, vă rog frumos.
Eu sunt la...
A doilea slide suntem.
Da, dar dumneavoastră vorbiți înainte deja, luați la trele.
Acum e... Pentru că la mine se schimbase, mă scuzați. Cum spuneam, calculul statistic pentru perioada supusă studiului ne arată că cel mai târziu îngheț a fost înregistrat la stațiile meteorologice Soroca și Kamenka la 10 mai 2017, ceea ce înseamnă cu 18 zile mai târziu față de data medie determinată în studiile anterioare, adică în studiile efectuate până în 2005, care corespundea cu data de 22 aprilie. De asemenea, și data de manifestare a primelor înghețuri cunoaște o careva diferență datorită impactului schimbărilor. Spre exemplu, deja în prima decadă a lunii octombrie se caracterizează prin probabilitatea apariției a primelor înghețuri de diferită intensitate și vedem că la fel aceste înghețuri au loc cu 20 de zile mai devreme decât în perioada anterior analizată. Ca concluzii, putem spune că în rezultatul acestor cercetări observăm clar influența care o are schimbările care au loc la nivel climatic și asupra datei de manifestare a înghețurilor periculoase, ceea ce constituie 18 zile mai târziu pentru înghețurile de primăvară și 20 de zile mai devreme are loc manifestarea înghețurilor de toamnă. Paralel cu aceasta, se poate de menționat că are loc și o majorare cu aproximativ 18 zile a duratei perioadei fără îngheț. Vă mulțumesc pentru atenție.
Thank you, Alena, for your presentation. Somebody have a question for Alena for her presentation? Thank you, Ms. Botnari. Olga Krivova from Institute of Ecology and Geography. Are you hear me? So after this section, there are poster session. Dr. Tsugulia Andrian is here. Please present your poster, Tsugulia.
Bună ziua! Îndată postez.
Și acum nu știu ce că să văd.
Spuneți-mi, vă rog, dacă se vede.
Da.
Da, bună ziua încă o dată. Vreau să prezint rezultatele obținute la tema privind investigarea influenței poluanților emiși de către transportul auto asupra proprietăților plantelor în ecosistemul urban Bălți.
Măriți o lecuț. Luați pe bucăți, așa, sus o măriți și apoi urmă, da, dați în jos. Hai.
Pentru cercetări au fost analizate specie de arbore Tilia cordata din ecosistemul menționat. Pentru început vreau să menționez că numărul unităților de transport atât în Republică cât și în regiunea de dezvoltare nord este în creștere. Dinamica poate fi observată în imaginea alăturată. Și pot să menționez că în municipiul Bălți, la data de 1 septembrie 2021, au fost înregistrate 49.453 unități. În figura alăturată este prezentată distribuția numărului unităților de transport pe principalele artere de circulație din ecosistemul dat. Și poate fi observat că în sectorul centru, strada Ștefan cel Mare este cel mai mare număr al acestor unități, urmată de strada de centură. Au fost efectuate și cercetări privind conținutul de clorofilă în frunzele speciei menționate, iar totodată și cantitatea totală de apă. Poate fi, în figurile alăturate poate fi observată că anume în sectorul centru, unde este și cel mai mare număr al unităților de transport, se vede că acest conținut este mai redus. Aceeași legitate poate fi observată și pentru conținutul de clorofilă, adică raportul dintre clorofila A și B în frunze. În concluzie, pot menționa că concentrația de emisii este în strânsă legătură cu concentrația de clorofilă în frunze și impactul, îmi cer scuze, am emoții, și impactul este mai mare. Mulțumesc!
Thank you for presentation, for your poster. Do you have some question for Andrian? Please, Dr. Inga.
Which language should I ask?
Maybe in Romania or
Ok.
in Russia.
Întrebarea mea este, cum considerați care poluanți contribuie mai mult la aceste schimbări pe care le observați? Poluarea cu metale, cu compuși organici? Ați încercat acest tip de studii să înțelegeți care poluare contribuie mai mult?
Din cercetările noastre putem menționa că anume emisiile gazoase au o influență mai nefastă asupra plantelor.
Portul, da.
Mulțumesc.
Plăcere.
Thank you for your question. Thank you for your answer. Please, if somebody from poster session, for example, Mr. or Miss Gnucik.
Yes, I'm here. Dear colleagues, nice to meet
please,
you. Nice to see you and hear you too.
Can you share screen with your poster?
Yes.
Please.
You can see my screen.
Yes, we can. Please, Ms. Gnucik, investigation of toxic compounds in the aerosol of tobacco heating system from Russia. Please.
I'm from All Russian Scientific Research Institute of Tobacco, Mahorka and Tobacco Products. And my work dedicated for investigation of toxic compounds in aerosol of the tobacco heating system. These products are popular in our country and in Moldova, I mean too. And we investigation of aerosol from these tobacco heating systems and compared with aerosol of cigarettes or tobacco smoke. We know that tobacco smoke consists of some toxic compounds, and the World Health Organization, these compounds is nicotine, is benzene, benzpyrene, acetaldehyde, formaldehyde, and some other. And these compounds in aerosol of tobacco heating system are very low, and you can see in my screen these graphs. But nicotine is not so low as other compounds. And we can see that nicotine about 17% or about 19% with a comparison of tobacco smoke. So these products as tobacco heating system, we can use as alternative from tobacco products, from cigarettes, as other compounds, as carbon monoxide, benzpyrene, butadiene, benzene, formaldehyde, acetaldehyde, and acrolein is very low by comparison with tobacco smoke, with reference cigarette. And a few words about reference cigarette. Reference cigarette is a scientific instrument. This is not commercial product, but this product in scientific researches. So these products as tobacco heating system can be alternative to traditional cigarettes.
Okay. Thank you for your report, for your presentation.
Thank you.
Dear participants, some questions? Thank you, Ms. Gnucik. Another poster is of Karkela Miss or Mr. Carchela, absence of solid particles generated from thermal process in the aerosol from an electrical heated tobacco product. There are some person with this presentation, this poster. Another author is Margarian Kachaturian from Armenia, in poster session. Mândru, Țurcanu. Nobody. So, in this case, we are at the end of this section with our climate change, atmospheric chemistry, both presentation and poster session. So if someone have a speech for the end or some question to the end of this section, please. Got it. So, in the end of this section, dear participants, as mentioned our director of the Institute of Ecology at the beginning of this section, we provide opportunity to exchange our work, our research work, scientific works between scientists from Moldova, from Russia, from Georgia, and other countries. So was discussed and present recent results on soil, air, water composition, air pollution, climate change. So we think the aim of this section and this presentation were touched. So communication among scientists, among engineers, among educators, teachers, or other professionals on environmental issues and sustainable development was done. So thank you for your presentation, for your poster session, and we all national speakers or who have presentation. We have some conference materials here at the Institute of Ecology and Geography, and when we have time, or you have time, please come to the Institute of Ecology and Geography for this bag with material of conference. Thank you for your presence, for your speech, for your presentation, and we would like to say final speech, Mr. No. Thank you, and see you soon in another section. Was a conference dedicated to academician Duca Gheorghe, a professor, president of Chemical Society of the Republic of Moldova, also the head of Research Center of Physical and Inorganic Chemistry from Institute of Chemistry. Happy birthday, Mr. Academician, and all the best for you.
Thank you.
Thank you. Thank you very much for your presence, Doctor. So, thank you.
La mulți ani pentru domnul academician.
Da.
Nu cred.